In this video, I will focus on ways to avoid mental DFS. So DFS is depth first search. Here, mental DFS means doing the following mentally. So first, you assume a move, usually one out of two options. Then you go forward as far as possible. And then you backtrack when it leads to a contradiction, and you take the other move. So I want to say that I'm not against mental DFS. On the contrary, if you have good visual memory, it can be very fast. Ezra does this a lot in his videos. However, for people like me with a goldfish's memory, it doesn't work very well. So the quick rules we've discussed in the previous videos can be applied to avoid mental DFS. You've probably seen the power of the triangle rule, which is the most common. For example, in both yesterday's and today's puzzles, you can start with the triangle rule and the rest becomes trivial. So green, green, red here. Green, green, red. Now we discuss some other tactics. So the first thing I find useful is to look for short lines or supercells. And here is an example from Ashley's article. So two ways of using mental DFS were mentioned here on the two cases of the top one here, or first eliminate this one and then eliminate this one. So we look for short lines. So here's one of these and one of this. Then you consider these two as supercells. Then you can have one here, which is two. One line here, and one line here. Usually the red lines are contiguous, without being blocked by black cells. But here, since this is a 1, we know that only one of these can be a bulb. So this line is red. So we can build this community here, and then eliminate everything in this column except for these two. Next, we notice that 1, 2, 3, 4, 5. There are 5 supercells. And 1, 2, 3, 4, and 5 red lines. So this is also a perfect community. Then we can eliminate this one, and this is a bulb. And we're done. Another very useful tip is the intersection rule. So we can build a community, and if it turns out to be imperfect, then we can see if there are non-neighbors at some of the intersections. So 2, 13. So here, I tried very hard, but couldn't find a perfect community. But let's try to see what happens when we build. I like this line because it passes through 3 home cells here. Also this one. 1, 2, 3. But since this is a shared neighbor, So this should count twice. And then you see this cell needs to have a red line here. And this one as well. So then do this and that. Now we have 1, 2, 3, 4. The value is 4, but we have 1, 2, 3, we have 5 red lines already, and we still have to cover this one. So maybe it's a good idea not to include this one. And then we still do it here and here as a single line, and then here and here. Now we have 3 home cells here. And 4 red lines. And this one here is not a neighbor, and it's an intersection. So this cannot be a bulb. Two here, 1, 1. See, survivor, 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 1. And we're done. Another example. So 1, 2, 3, 4, 5, 6. And 3 and 3 is 6. So we have these 3. One here. 1, 2, 3, 4. 2 and 2 is 4. One here. 0 here. 1 here. 0, 1, 1. So at this point, I cannot go any further. See if we can build some communities. Like it's these two already taken care of. One thing I find useful is we look around hubs. So for example here, this is a hub. So if we draw red lines, 1 here, 1 here, and 2 here. Then the intersection, which are non-zeros, non-neighbors here. So this here is passed through by 3 red lines. And we only have 1 left, which cannot cover 2 home cells. So this is excluded. This is as well. Here, 0, 1 here, 1 here, 0, 0, 0, 1, 1, 1, 1, 0, 0. And we're done. One last thing. Sometimes there are too many ways of building imperfect communities. And it's better to do the opposite. So first, we find a non-neighbor, and then we build an imperfect community based on this non-neighbor. Let's look at an example here. So first we do 1 and 1. 1 and 1 here. 1 and 3 is 4. 1, 2, 3, 4. 1 here. 3 and 1 is 4. 1, 2, 3, 4. 1 here. 0 here. And now you can see that most of the candidate cells are neighbors, except for these 2. But this one is the intersection of this and that. This is useless. So what if we start from this non-neighbor and see what kind of community can we take advantage of? So this is a non-neighbor we're focusing on, and let's draw an intersection. Now you see this needs to go out somewhere. Here. And we don't need this line code, right? Because neighbors have already been covered. Now we have, what's the home value here? 1, 2, 3, 4, 5. And the number of red lines is 1, 2, 3, 4, 5, 6. And this is a non-neighbor and an intersection, which means this one must be eliminated. Okay, now this one has a hero here, one here, one here, one here, one here. Now we're done. One last example. For 314, you can do it as an exercise. So 1 and 1 is 2. 1, 2. So 1 here, 1 here. 2 and 1 is 3. 1 here, 2, 3. Now this one is a supercell. 1 and 2 is 1 and 1 is 2. One line here, another line here. So this is a hero, survivor. Now we can see we have 1, 2, 3, 4, 5, 6 non-neighbors. But for these two, this direction is useless. And for this one, this direction is useless. For this one, if we can eliminate that, then we immediately get this as a bulb. So this can be very useful. For these two, we don't see the immediate effect. Well, in fact, I encourage you to assume to start with this or this and see what you can draw. I think you can still eliminate this, but after that, there's nothing else you can do about it. So we try this one. So this is an intersection of this one and this one. Then we go here, 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 and finally here. Now we have home value of 5, and all the neighbors have been covered. But we have 1, 2, 3, 4, 5. We have 6 red lines, which means it is imperfect. But this one is a non-neighbor and an intersection, so we can exclude this. Now hero, 1, 1, 1. Lastly, green, green, red. So this is a bulb. And we're done. Thanks for watching.